Hello guys, this is Wasim Khan. I'm a mechatronics engineer and welcome to my channel Design and Simulation in Mechanical Engineering. Now guys, in the previous videos I have done most of the task for the press arm assembly that I have designed and simulate, and we have performed almost 3 videos for the complete analysis of this press arm. Now in this video I will show you how to do the fatigue analysis of this mechanical press assembly. So let's start and we have nothing much to do in this section because fatigue analysis is not a very cumbersome task, as it is like the static analysis or the topology that we have performed in the earlier part 1 and part 2 of my videos. So let's start with the fatigue analysis of this mechanical press arm, and now I will show you how I set the boundary conditions for the fatigue analysis simulation. So guys, as I have already told you that I applied the grey cast iron to all materials. So the grey cast iron have an SN curve of you have to put the SN curve of the grey cast iron, and if you are not found this data in this chart, so you have to go to file and you have to select cast iron there, and you will see the SN curve of the cast iron. So you have to click OK, cancel, and there the SN curve will appear. Now apply this SN curve and it will automatically insert the SN curve of the cast iron for various stress cycles. Now the loading type is up to you, that how your model behave according to certain loads. Now there are 4 types of load acting. The first one is the fully reversed. Fully reversed means that the loading type reverses every cycle. For example, if a load is applied in the positive direction, then also there will be a negative force of the same value in the opposite direction. So you have to select the best type of loading conditions that your model have been under. So in my case I have applied fully reverse load, and I have taken this data from my static 2 analysis that I have performed in the static analysis. As I have shown you this static analysis, and you can see the static 2 analysis have a pressure load on this plate. Now this fatigue data is for the pressure load, and now we see the results of the fatigue analysis data. Now if I select the damage, so the maximum damage for this is about 0.344%. Now if I go to chart options and select where the maximum percentage of damage occurs, so it will show us the location of the greater percentage of damage on the part. So here you can see the portion of this hole is red, and here the maximum damage will occur, because this is the fixed support, and this flange or this assembly arm is moving between the power screws. Now we can see the another parameter, that is the life. Now the life, the minimum we can uh, uh, bases this model on the minimum life cycle. So the minimum life cycle for this model is 2.9 into 10 power 5 cycles. Now it shows us that if a fully reverse loading type of 5.29 million cycles act on this plate, then the life of this continuously act on this assembly, then the life of this plate will end. So you can see there the minimum life occur on these locations. But if we look at the normal life of fatigue life of certain steel and iron materials, it is about 10 power 6. So it is almost near to the 1 million cycles. And for my case, uh, it is okay for me. Now if we check the load factor, the load factor comes out to be 1.65, and the load factor means the fatigue safety factor. So the fatigue safety factor should be greater than 1 to make the model behave or make the model reliable under certain loading conditions. So 1.657 is good for me. Now I have a target value of 1.5, and it comes out to be greater than 1.5, so it is good. And now in the next fatigue analysis, we can see how this assembly behave under the force load condition. Now everything is the same, and now we want to generate the data. So there you can see the damage percentage is 0.533, a little greater than the previous fatigue data when we applied a pressure load on this model. So you can see the little differences between force and pressure load types, and it is about 1.8 into 10 power 5, about 0.2 million cycles. And there in the previous fatigue data, the minimum cycles were 0.29, so not much difference there. And if we see the load factor is almost the same. So the load factor comes out to satisfy our conditions, our requirements. So it is okay for me to be at this value and accept this model for as a good and statically stiffer. So guys, this is the whole process of the design of the arm assembly. And now if you have any question, please comment below in the comment section. And if you like my video, please like and subscribe and click the bell icon to see more notification of my videos. So guys, thank you very much.